Hello. So we tackled this weekend the problem of classification of IFC models. So first, a small introduction. What is classification to begin with? Classification is a process of filtering, grouping, categorizing a variety of IFC objects in the model by a humane definition. So for example, you want to group all the fire safety doors, or you want to group all the roof elements, or all the elements that need to be watertight. And currently, how that happens in our everyday practice in BIM coordination projects is usually that in the contract they ask to add lots of additional attributes. For example, you literally need to mark down in the object that's a fire safety door, and then it gets read into the checking program, and then it gets categorized based on this manually defined property. This adds quite some bloat to this BIM project, and we want to add a solution to it by creating a platform, an open framework to automate this categorization, to remove all this bloat from the models and make this categorization process a lot smarter. So we called our pet project for this weekend Classy.io. And what the main strategy is of Classy.io, we were discussing yesterday, how should we solve this problem? And we found out that you can't solve this very complex and very flexible, wide specific problem with just one super smart algorithm. So our strategy is to throw lots of algorithms on top of it that are not all 100% accurate. But the idea is if you throw enough very different algorithms and technologies and programs and softwares on top of the same problem, and there is an overlap, you might find a solution with a very high probability. So what would it look like in a concrete app? So we made a web interface where, for the same problem, we run multiple checks, and then in the end it gives you the average of all these very different kinds of checks. So because a weekend is just a very small time, we could only tackle one kind of classification, and we took the problem of identifying balconies in the IFC model. We had four main strategies to do it. So one is geometric skin wrapping. Second one is using visual recognition and large language machine models. Then we had an approach of looking directly in the IFC data, generating graphs, and do pattern recognition, see if we can find elements from there. And the last one is that we want to look at the neighboring objects, and because of this geometric neighboring relation, we want to find the host objects that we're actually looking for. So this weekend, in the course of this small time span, we only made prototypes of two of them. So first of them is the geometric skin wrapping.
Yeah, I'll do it. Right, yeah, so shrink wrapping, but yeah, skin wrapping would be cool. This is a purely geometric approach, so we normally have IFC files with attributes, but let's imagine for a moment that we also have alternatives, other solutions that check these things without knowing their attributes. This can also help us know if the attributes are correct or not, for example. So for this one here, we take all the elements and we try to make one watertight mesh that covers all of them. Thankfully, thanks to Rhino 8, this is actually quite doable nowadays with this shrink wrap machine that generates, in the end we have this very, very exact. It only takes less than a minute to calculate this really good mesh. And now I want to know all these elements here, right? These balconies, these stairs, these are obviously something that I would want to find automatically. How could I do that with purely geometrical approaches? Well, the first thing I do is I take this mesh that I created with Rhino and I offset it inside, some 40 centimeters, something like that. Offset it outside again, and you can already see all this stuff disappeared because it's all smaller than 40 centimeters and it's outside of the building. Now just to check it, I find the center points of each of these objects. Are they outside of the mesh? They might be a balcony. So as you see, it's a pretty simple approach. We even tried it on this other building and it worked quite well and super fast. On the other facade too, the only thing, it did detect the chimneys on the top, but we would assume that you could then check, as we were saying, you would have different checks, and one of them would checking, is it a slab? If it's not a slab, and if someone categorizes their chimneys as a slab, well, they have bigger problems. So this would be the geometrical approach here. And the next one.
Yeah. Then, of course, we also asked ChatGPT just to make sure that it's not that easy. So we've done some screenshots here, and we've uploaded them and said, ChatGPT, please highlight all the balconies. And that's the result. Of course, this is not the only thing that we've tried with ChatGPT. We've tried also with the metadata, with JSON files, because ChatGPT cannot read IFCs. But then we have limitations. So basically, this could be one of the approaches that you go through the API. We've seen chunking and chaining and so on. So this is for sure one direction that you can improve just to get even more certainty. Also from another angle, so it's highlighting something, but it's really not the thing that, yeah, and just to mention here the screenshot from Zurich, of course, to visualize something, but this is, yeah, in the scope of a weekend, how far we got. And then we get to the demo.
All right. So that was like just a front-end thing. Where did you put the?
Just here.
Yeah.
Just press it.
Ah, it's already open. Okay. So you can like it's basically a svelte front end. So you can basically just open up the project and then like start. All right. Checking different like evaluation models, and then start running like a classifiers, and like this could be like very differently. So you could like have the ChatGPT approach, or like the shrimp rack, so you can like chain them together in the end. So
Next slide. Great. That was a front-end approach, or just experimenting. As was mentioned, we took sort of different approaches trying to get to results and solutions so that we can present something useful at the end of the weekend. And the approach here was to take all those models, exactly as what was explained earlier, and then, by the way, this is a published application. So just a bit of background. For example, the grasshopper model was integrated with this web-based application. All of this was just written with Python and integrating there. And so here you can, if you have, go to our GitHub repository, you can actually go and get this or play around with this application. And here, hopefully, it will then classify. And boom. And there we have it, a classification that was done. And this was done with the single classification method, which you then can also, the classified results you can download, but you can also select any others, or multiple, or whatever you would like. So that's that.
So for the ones that are interested, there's a link to our GitHub. Feel free to scan it and contribute to the project, because it only works if we collaborate on the library together.